welcome to the deep dive. We're diving into this pretty complex stuff this time. This article you sent over on string theory. I have to admit, it's a bit of a head scratcher.
Oh, yeah.
Yeah, it even mentions Pythagoras and music.
Hmm.
Color me intrigued. So let's see if we can unpack this together.
Okay, yeah, sounds good. What really fascinates me about all this is, well, this idea of a theory of everything,
Okay.
A single framework to explain the whole universe.
Yeah.
The smallest particles to the largest galaxies.
Yeah, that makes sense. But from what I got from the article, our current theories, Einstein's theory of relativity and quantum mechanics, they don't really work well together. They each work amazingly well in their own, realms.
Yeah.
But when we try to combine them,
Yeah, you're right. You hit the nail on the head. Imagine this. Einstein's theory, it's like a huge symphony orchestra, right?
Okay.
Beautifully describes the movements of planets and stars. But then you zoom in to the subatomic world. It's like you suddenly switch to a jazz ensemble.
Oh, okay.
The rules are different. Things get a lot more improvisational.
That's a good analogy. I like that.
Yeah.
So we have these two incredible theories, but they each just tell part of the story, right?
Yeah,
And that's where string theory comes in.
exactly. String theory says that all those fundamental building blocks of the universe, particles, forces, they're not really points. They're tiny vibrating strings.
Okay.
It's a pretty radical idea, but it has the potential to unify those two seemingly incompatible worlds of physics.
So the article quotes Michio Kaku, the physicist. He describes string theory as a finite theory that, unlike others, doesn't explode or collapse, as he puts it. I have to admit, though, all this talk of strings, it's a bit hard to visualize.
Yeah.
Do you have an example, anything to kind of help understand that?
Oh, absolutely. Michio Kaku uses a really wonderful analogy. Imagine you're looking at just a simple electron through this incredibly powerful microscope.
Right.
Instead of this tiny point, you'd see a tiny vibrating rubber band. That's a string.
Yep. No,
And just like a guitar string can produce different notes depending on how it vibrates, these tiny strings, they create different particles
interesting.
based on that vibration pattern.
Okay.
Yeah.
I'm starting to get the picture.
Yes.
But what does any of this have to do with Pythagoras?
Right.
I mean, I know he was a genius mathematician, but I mainly associate him with geometry, not really physics.
Well, this is where things get really interesting. Over 2,000 years ago, Pythagoras, he made this groundbreaking observation. It was about the relationship between music and mathematics.
Okay.
He noticed that the different notes produced by lyre strings, the lyre,
Right.
they correspond to very precise mathematical ratios.
So he realized that the harmony in music has a mathematical basis.
Exactly. That's it.
Okay.
And this led him to speculate, that maybe the whole universe was structured according to similar mathematical harmonies.
Wow, that's pretty profound for someone living so long
Yeah.
ago. Is this where the connection to string theory comes in?
You got it. Just like musical notes coming from different vibrations of a string theory, well, it proposes that different particles in the universe, they emerge from different vibration patterns of those fundamental strings.
So if we could somehow listen to those vibrations, we'd hear a cosmic symphony?
That's a beautiful way to put it. But now string theory it's still a very theoretical framework. Some of its predictions are hard to test directly.
Right. I was going to ask about that. The article did mention that some critics question whether string theory is even provable.
Yeah.
But then it goes on to talk about how string theory might shed light on some big mysteries in the universe, like black holes.
Right.
How does that work?
Black holes are these incredibly dense regions of space-time, where gravity is so strong that nothing, not even light, can escape.
Right.
They're a challenge for physics. For example, what happens to the information that falls into a black hole?
Right.
Does it just vanish?
And that would violate the laws of quantum mechanics.
Exactly.
I see the problem. So what does string theory have to say about all this?
Well, string theory suggests that the information swallowed by a black hole, it isn't destroyed, it's actually encoded on the surface of the black hole in the vibrations of the strings.
That's a pretty wild idea. So instead of disappearing forever, the information is kind of preserved on the surface of the black hole.
Exactly, like
Yeah.
a cosmic hard drive storing the data of everything that falls in. Now, we can't directly observe this, but the way string theory resolves this paradox, the information paradox, it's a big plus for the theory.
So not direct proof, but it does offer a potential solution.
Yeah.
to a major problem
Right.
in physics. Are there any other mysteries that string theory might help explain?
Well, one of the biggest ones is dark matter, this invisible substance that makes up most of the matter in the universe, and we have no idea what it is.
Yeah, I remember reading about that. Astronomers can see its gravitational effects on galaxies,
Mm.
but they can't detect it directly. It's like this cosmic ghost.
That's a great way to put it. And string theory suggests that dark matter, well, it could be made up of strings vibrating at higher octaves than we can currently detect.
Hold on. Higher octaves. Are we talking about music again?
It might sound strange, but think of it this way. Just like a just like a guitar string can vibrate at different frequencies to produce different notes, string theory says that these fundamental strings, well, they can also vibrate at different frequencies, creating different types of particles.
So dark matter's like a hidden symphony,
Yes,
playing on strings that are tuned to frequencies we can't hear yet.
that's a beautiful analogy. And it highlights how string theory could help us understand the universe in ways we never even imagined. Like we're just beginning to tune into the cosmic orchestra.
This is already blowing my mind. We've gone from Pythagoras,
Yeah.
the music of the spheres, to black holes and dark matter.
Yeah.
And I have a feeling this is just the beginning of our deep dive.
You're absolutely right. We've just scratched the surface.
Uh-huh.
Next, we'll delve even deeper into those implications of string theory and explore its potential, to really revolutionize our understanding of the cosmos.
Okay, so my brain is already buzzing from all this talk of vibrating strings and cosmic symphonies,
Hmm.
but I'm ready for more. You mentioned that string theory might help us understand dark matter.
Yeah.
Can you explain what these higher octaves of string vibrations actually mean in terms of dark matter?
Sure. Think of it like this. When you pluck a guitar string, it vibrates at a certain frequency,
Right.
produces a specific note. But if you press your finger down on the string, you shorten it, right?
Uh-huh.
You can make it vibrate at a higher frequency,
Yeah.
higher note.
Okay, I get that.
Yeah.
But how does that relate to dark matter? Are we saying that dark matter is made of strings that are like shorter?
Not necessarily shorter, but vibrating at higher frequencies that correspond to different types of particles.
Okay.
The idea is that dark matter, it could be made up of these exotic particles that, they interact very weakly with ordinary matter and light,
Right.
making them, well, incredibly difficult to detect.
So it's like dark matter is playing this completely different tune
Yeah.
on the cosmic string instrument.
Yeah.
One that's beyond our ability to hear.
That's a fantastic analogy. And it's one of the reasons why dark matter is so elusive. It's like we're trying to detect a faint whisper amidst a symphony of other sounds.
So if we could somehow tune our instruments to these higher frequencies,
Yeah.
we might be able to finally detect dark matter.
Exactly. That's one of the exciting things about string theory. It could give us that theoretical framework to develop new tools and technologies to detect these hidden particles.
That's really cool. This is all incredibly fascinating, but the article also mentioned something about dark energy. It says that string theory might shed some light on this mysterious force that's causing the universe to expand at an accelerating rate. How does that fit in?
Dark energy is, well, it's another one of those cosmic mysteries that keeps physicists up at night.
Right.
It seems to be this force, this pervasive force that's pushing everything in the universe apart, almost like an anti-gravity effect.
So it's not just that the universe is expanding, it's expanding faster and faster over time.
That's right.
Okay.
And here's
Sure.
where string theory comes in, again, with its mind-bending possibilities.
Yeah.
Remember those extra dimensions we talked about, the ones that are curled up at these incredibly tiny scales?
Yeah, the garden hose analogy. You said that from far away, a garden hose looks like a one-dimensional line.
Right.
But up close, you see it has that second dimension. Curled up circle.
In a circle.
So
Exactly.
are you saying that these hidden dimensions
Yep.
could be playing a role in dark energy?
Exactly. Some physicists believe that the energy associated with these extra dimensions, it could be contributing to this accelerated expansion.
Okay, now my brain is officially starting to hurt. So it's like these extra dimensions, they're adding a kind of hidden energy to the universe, pushing everything apart at an ever-increasing rate.
It's still very much a hypothesis.
Yeah.
But it's one of the really intriguing possibilities that string theory opens up.
The more we talk about string theory, the more I keep coming back to this analogy of the universe as a giant musical instrument.
Yeah.
Is that just a poetic metaphor, or does it have any real scientific basis?
It's more than just a metaphor. The math that describes string theory, it is very elegant and complex, but it does bear a striking resemblance to the math that describes musical harmony.
So you're saying there's a deep mathematical connection
Mhm.
between the way strings vibrate in string theory
Mhm.
and the way, sound waves create music.
Precisely. And this has led some physicists to think that maybe the universe itself is a kind of grand symphony orchestrated by the vibrations of these fundamental strings.
Wow. That's a beautiful and awe-inspiring idea. But if that's true, what does it mean for us? Are we just tiny notes in this cosmic symphony, or do we have a more significant role to play?
That's a profound question, that takes us beyond the realm of physics into philosophy and spirituality.
It seems like string theory is not just about understanding the physical universe. It's also about understanding our place within it.
Absolutely. It challenges us to think about the universe in a fundamentally different way, to see connections and patterns that we might have missed before.
We've covered a lot of ground here today, from dark matter and dark energy to the idea of the universe as a musical symphony.
Right.
But there's one more topic I want to touch on before we wrap up this deep dive.
Okay.
The article hinted at the possibility of a multiverse, a vast landscape of multiple universes.
Yeah.
Can you tell us more about that?
Of course. The idea of a multiverse, it is one of the most, well, it's mind-boggling and controversial predictions of string theory.
I can imagine. So are we talking about like parallel universes, alternate realities, things like that?
It's even more radical than that. String theory suggests that our universe, it might just be one bubble in this vast cosmic foam of countless universes.
Yeah.
Each of those universes would have its own unique set of physical laws and constants, perhaps even different dimensions of space and time.
Whoa, that's a lot to take in. So there could be like an infinite number of other universes out there. Some maybe with completely different forms of life, or even different laws of physics.
It's a wild idea, but according to string theory, it's a real possibility, and it raises all sorts of profound questions about the nature of existence, our place in the grand scheme of things. It's almost too much for the human mind to grasp.
It certainly stretches the limits of an imagination. But this deep dive has been all about pushing those limits, hasn't it?
It has indeed. We've explored some of the most complex and mind-bending ideas in modern physics, but ultimately it's all about seeking a deeper understanding of the universe and our place within it.
Well, I'm ready to explore even further. In our final segment, let's delve into those philosophical implications of string theory and see if we can make sense of what it all means for our understanding of reality. Okay, we're back for the final part of our deep dive into string theory. And I have to say, this has been one wild ride. We've explored everything from tiny vibrating strings to the possibility of, countless other universes.
Yeah, it's a lot to take in.
It's enough to make your head spin.
It's true. String theory really stretches the limits of our imagination, but that's what makes it so compelling, I think. It
Yeah.
forces us to confront these really big questions about the nature of reality, our place in the cosmos.
Exactly. So for this last part, I want to kind of step back from all the technical details and explore the bigger philosophical implications of string theory. If everything is ultimately made up of these vibrating strings, what does that tell us about the nature of reality itself?
Well, for one thing, it suggests this profound interconnectedness, between everything in the universe.
Okay.
Think about it. Every atom in your body, every star in the sky, every galaxy, swirling through space, they're all ultimately made up of these same fundamental strings, just vibrating at different frequencies. It's like we're all part of this one giant cosmic tapestry,
Yeah.
woven together by these invisible threads of energy.
That's a beautiful image. It reminds me of some of those ancient Eastern philosophies,
Mm.
that talk about the unity of all things.
There are definitely some interesting parallels there. Many spiritual traditions, they emphasize that interconnectedness,
Yeah.
of all beings and the universe as a whole. String theory, in its own way, seems to be pointing toward a similar understanding.
Yeah. It makes you wonder if there's some kind of deeper meaning to all of this. If everything is connected at this fundamental level,
Right.
does that imply some sort of cosmic purpose
Yeah.
or design?
Well, that's a question that has puzzled philosophers and theologians for centuries. And
Yeah.
string theory doesn't, it doesn't necessarily provide any definitive answers, but it does offer a new perspective on this age old debate between chance and design.
So instead of seeing the universe as this random collection of particles,
Yeah.
string theory suggests a more intricate structure, possibly hinting at a deeper level of order.
Exactly. And that raises all sorts of fascinating questions about the nature of consciousness,
Yeah.
the role of observers in shaping reality and the possibility of a universal intelligence.
Okay, now my mind is really starting to melt.
It's a lot to ponder.
But I love it. This is the kind of deep thinking that I crave. We've talked a lot about those scientific implications of string theory.
Yeah.
But it seems like it also has the potential to revolutionize our philosophical and spiritual understanding of the universe.
Absolutely. String theory it isn't just about physics. It's about pushing those boundaries of human knowledge and exploring the deepest mysteries of existence.
Well, I think we've reached the end of our deep dive, and I have to say it's been an incredible journey. We've explored those frontiers of physics, contemplated the nature of reality,
Yeah.
and even caught glimpses of other universes.
It's been quite a ride.
It's been a truly mind-expanding experience.
It's been a pleasure sharing this exploration with you, and I hope our listener is now inspired to continue their own deep dive, into the mysteries of the universe.
That's what the deep dive's all about. So to wrap things up, I'm going to leave you with this final thought. If string theory is correct and the universe is a symphony of vibrating strings, then we're all part of that symphony. We are all interconnected, all vibrating together in this grand cosmic orchestra. And who knows, maybe someday we'll even learn to compose our own music on those strings of reality. Until next time, keep seeking, keep questioning, and keep diving deep